Hello there. In this class we are going to be discussing a problem that we call overflow. Now what overflow is a situation where whenever a computer is performing an arithmetic operation, the result of that arithmetic operations whenever exceeds the size of the register, we call this situation an overflow. Now let's give an example here. Let's say I have got three registers here. R1 is storing A, R2 is storing B. A and B are both in some numbers, random numbers, and I want R3 to store the result, the sum of these numbers A and B. Now there is a possibility that the sum or the result of this A and B may exceed this size of register. There's a possibility, right? This may not fit in here. So this possibility, this situation, whenever it happens, this situation is known as overflow. I'm going to give some examples in the future so you will understand it properly. Now when does overflow arises? When does overflow occurs? Now overflow mostly occurs whenever we are performing addition between two positive numbers or addition between two negative numbers. Let's say I have a register of, let's say, 5 bits. So mostly a 5-bit register can store numbers from, if I am using 2's complement, it store numbers from minus 16 to plus 15 if I am using a 5-bit register. And if I'm using 2's complement, in that case this is going to be the range by the formula. If you haven't discussed these things, I'll give the link in description. You can go to like that video of mine where you will get this range of registers in case of 2's complement and in case of 1's complement too. Let's say in this case, if you have 5-bit numbers, let's say 8 can also be represented in 5 bits, 10 can also be represented in 5 bits. Now if I try to add these things up, 8 plus 10 becomes 18. Now 18 doesn't comes in this range. So in this case, this problem is called overflow. You can also do the same in negative numbers too. You can simply like negate this one. Let's say I inverted both of them. Minus 8 and minus 10 will be also minus 18, which again doesn't comes in this category. So this situation is known as overflow. Now let's come to binary. How do we do it in binary? But before that, let's see why overflow occurs. Now overflow occurs because whenever a register is created, it's given a range, it's giving a size. Just like I gave 5-bit register, mostly I'm using 5-bit register, so I can create a range for my 5-bit register. This n can be replaced with 5. So if I do 2 power 5 minus 1 to 2 power 5 minus 1, what will I get? I'll get minus 2 power 4 to 2 power 4 minus 1, which will become, this will become minus 16 to plus 15, because I am subtracting 1 from my 16. So this is the range. It means that whenever I perform any operation, arithmetic operation, the result must be inside this range. It must be between minus 16 and plus 15. So otherwise what will occur? Otherwise overflow will occur. Due to this range, overflow mostly occurs. Now let's try to give an example for this. Let's say I have got two numbers here, 9 and 10. Now if I want to involve complements here, I wouldn't need these two things. I would need negative numbers, but let's go with this. Let's say I have negative numbers, two negative numbers. Let's say if I'm trying to add up these two numbers, these two negative numbers, what will I do? Now both are negative numbers, they have got their binary equivalents in front of them. What can I do? I can simply find 2's complements of all these numbers. So 2's complement of this will become 1 1 0 1, and 2's complement of this will be 1 0 1 0 1. Yeah, now if I try to add up these, now 1 plus 0 will be 1, 1 plus 0 will be 0, and 1 plus 111 will be 1, and it will come up with a carry. 1 plus 0 will be again 1, 1 plus 1 will be 0, and a left around carry will occur here, but I'll definitely discard it. Now let's see this number. This number doesn't make sense at all because I am adding two negative numbers. So this means that the result will also be negative, but as we have used sign magnitude, it means that the most significant bit is the sign bit. This is not the magnitude bit. This only represents the sign. Now this is 0. The result should be positive, negative na, but here is 0, 0 means positive. It means that there is some problem here. Whenever this kind of invalid solution arises, whenever this kind of invalid result arises, we say that overflow is occurred. Now look at these numbers 9 and 19, and we have 5 bit register. We already discussed that it's going to range from -16 to +15. Now 19, which is the result of these two arithmetic operation, doesn't comes in this category, it exceeds this. That is why we are saying that this is the overflow. So I hope you understood it a little bit. This is quite a bit tricky concept, but we will definitely come up with more videos on this one to make it simpler and simpler and to make you guys understand properly. So in the next video we are going to be discussing how do we perform subtraction using 2's complement, and we will do some examples on that too. So keep following us and keep supporting us.